Nvidia just released their ChatRTX application, which is pretty impressive and solves the two biggest issues with LLMs today. Issue number one, data access. Now sure, I can copy in the contents of a file or an email, I can upload a few documents to a model, but it starts to get tricky when I want it to have access to hundreds of different documents, or my entire operating system or entire directories on my computer. And even if I could give a model access to all of this information, would I want to do that? Would I trust a company with all my private and sensitive data? That's where issue number two comes in, privacy. We really cannot trust these central companies. We don't know what they're doing with our data, if they're training on it, if they're storing it. And I don't know about you, but I don't want random companies having access to my personal information. But at the same time, it would be super cool if I had a model that could answer questions about my personal data, read through my files, go through sensitive documents, and do that in a secure way where I can still get information really quickly, but I don't have to be worried about this being sent off or sold to some company. Now, fortunately for us, Nvidia's ChatRTX application pretty much solves all of these problems by running a free open source model locally on your computer, which has access to all of your different files. That means I can ask it questions about my information, get responses back extremely fast, and know that all of my data is secure because it's not connected to the cloud. A big thank you to Nvidia for sponsoring this video, and let me share with you a quick demo of how this tool works. So this is what the application looks like. It's pretty straightforward, and this is just running locally in my browser, and I'll just quickly walk you through how it works. So you can see that we can select a model that we want to use, so Mistral, Llama 2. We also could install other open source models if we want, and then we have a dataset section. Now the dataset section is the cool part here, where I can actually select a directory on my computer that I want to give the model access to. Now what this will use is something known as RAG, which is Retrieval Augmented Generation. I'm going to talk more about that later in the video, but the idea is you can give the model some context about different files on your computer, and this is all secure, running locally, and it's super fast, and it can look up information, find different things inside of, for example, PDF documents, text documents, or Microsoft Word documents, and then immediately give you the result. So let's test something out here. I'll say, can you give me a summary of my script related to microservices? So this directory has a bunch of different files. One of them is a microservices script for my YouTube channel. And you can see that what it does here is it finds this document, gives me a reference to it that I can click on, and then it actually gives me a quick summary of that script. So this is super cool, and you can use this to really quickly look up different information and to have access to all of these different files within the model. So let's imagine you had a directory with your flight itinerary and a bunch of different plans, and maybe someone asks you, hey, what are you doing on Thursday? Rather than having to go through there and look for the information, just say, hey, what am I doing on Thursday based on my flight plans or based on my itinerary? Point it to that directory and you instantly get that information. This is super, super cool. I'll type in a few other examples here so you can get a sense of how it works. So I just selected another folder here, and this folder actually contains a bunch of accounting information for my business. So invoices, receipts, tax information, etc. Now this is highly sensitive data that I wouldn't want to share with other people, but that I might want to quickly get some information about without having to go search through all of the different files. So I'll just show you an example of doing that here and obviously blur anything out that's going to be too sensitive. So I can say, can you give me some information about my invoices to Course Careers? I've done some development work for Course Careers. That's the company that I have my software development course with. And you'll see that it starts going through here and listing all of the different invoices that I've sent them, giving me the information about it. I kind of need to blur some of this out because I can't show you guys everything that I've done for them. But yeah, it kind of walks through how that works, right? So invoice number 128, invoice number 115. And this is information that would usually take me at least a few minutes to find. And it's quite cool that it can just really quickly look it up and share it with me in a quick summary view here. So I just asked it another style of question here. Can you find all of the receipts related to video editing? Obviously I was able to do that. It did that super fast, by the way, as well. And that's the number one thing I've noticed with this. It happens almost instantly. I guess that's because it's running locally. But with a lot of other models I've used, they're quite slow, especially the ones that are hosted online. I'm being rate limited. I'm waiting on, I don't know, a bunch of other people to get their replies. And sometimes I sit there for 2, 3, 4 minutes waiting for a long reply to be generated. Whereas this, it seems to happen almost almost instantaneously. I love this for looking up information, and I can already think of a bunch of different ways I could use this to really speed up my workflow, especially when I'm trying to find different documents or files, which for me is a bit difficult to do, especially if I don't know like the file name or a specific way to search it. Here I can just use some natural language, which is not something I'd be able to do in like the Windows search bar, right? So now that we've looked at a quick demo, let's talk about how you can start using this on your own computer. And trust me, it's quite a bit cooler when this works on your own machine and answers questions about your own data and files rather than seeing it work on mine. Anyways, it is a free download. You can get it from the link in the description. Just keep in mind it is demo, and there are some pretty steep system requirements, so let's get into those. So first of all, the platform is Windows. It's not going to work on Mac or Linux, and you do need to have an RTX 30 or 40 series GPU with a minimum of 8 gigabytes of VRAM. Now that's because this is using RTX features to actually work properly, so you do need a newer GPU in order for it to work. Now you're also going to need 16 gigabytes of normal RAM, and you're going to have 35 gigabytes of disk space. This download is 35 gigabytes. It took me an hour to download it, and then going through the installer took almost 30 minutes where it downloaded and installed a bunch of other stuff as well. So realistically, you're probably going to need even more than that, maybe 60, 70, 80 gigabytes of space on your computer. That said, it is pretty cool, and obviously it's all running locally, so like that's kind of the price you have to pay, right? If you want ultimate privacy and security, you're gonna have to run it on your own computer, which means you need a pretty insane computer with pretty high-end specs in order for this to actually work. In my case, I'm using a 4090 with 64 gigabytes of RAM, and it's working extremely fast. So with all of that said, let's quickly talk about how an application like this works. Now, the first thing to understand is that behind the scenes, we're really just using an open source LLM. Now, the LLMs that come with this by default are Mistral and Llama 2. Llama 2 is the one provided by Meta. Open source just means it's free. We can use it however we want. We can modify it. We can fine tune it, different than a closed source LLM where we don't actually have access to the code. Now, that's one of the reasons why the file size is so large here, because we're actually downloading these LLMs and we're running all of their code on our local computer. Now, what we do with these LLMs is we add additional data to them using something known as RAG. Now, before we dive into RAG, let's understand how a normal LLM would work. So if I just go to a normal LLM and I ask it a question, it can generate a pretty good response for me, but it can only give me data based on what it was trained on. So if I try to ask it, what's the most recent YouTube video that Tech with Tim posted, it's not going to be able to tell me that because it wasn't trained on that information. It doesn't have access to that data. It does have access to a bunch of historical facts. It knows how to generate replies. It can write code for me. It could do a bunch of awesome stuff. But when it comes to data availability and knowing kind of up-to-date or recent information, that's where it really struggles. So that's why we have something called RAG. RAG is retrieval augmented generation, and all this does is add information into the LLM that it can then reason based on. It's just like taking the relevant information, giving it to the LLM and saying, hey, now use all of this new data and generate replies. So obviously that's going to give us better, more contextually relevant replies, but there are some issues when it comes to giving so much data to an LLM. So we can't actually just give the LLM all of the information we want it to work on. We have to be a little bit more sophisticated and inject the right pieces of information with the prompt, or in whatever way we're going to end up doing this, so that it gives us the right reply. So this is where the next stage comes in, which is actually retrieving the information. So what we'll first do, kind of the first step when we ask a question to a RAG application, is we're going to go to something known as a vector store database, and we're going to look up information relevant to the prompt that we've provided. So we'll type in some prompt, we'll ask some question, we then will go to a vector store database, which I'll talk about in a second, and we'll pretty much look up information related to that prompt. We'll then get snippets of information from our data set. We'll take that, we'll provide that to the LLM, and we'll pretty much tell the LLM, hey, now use this data and answer this prompt. Then it will do that, and based on the data we've given it, it will give us a better, more contextually relevant reply, as you saw when I was in that demo. Now, how does a vector store database work? Well, I don't want to get into this too much because it's a bit complicated, but the first step is that we're going to take our entire data set, so in this case, all of our files, and we're going to create something known as a vector embedding for them. Now, a vector embedding is a representation in multidimensional space of the meaning and the context of a piece of data. Now, what we do is we take all of our data, we vectorize it, we put it in this database, and this gives us a really fast, efficient way to find different pieces of data. So rather than searching through the entire database looking for every single piece of information that may be relevant, we search using vectors. Again, we don't need to get into the complexities, and we can really quickly find the relevant information that we want and give that to the model. If you're curious, you can read more about this and you can learn about vector databases, but the idea is the first step is take all of our data, create these vector embeddings, which can take a little bit of time to do. We're going to store those vector embeddings, and then we're going to use them when we actually want to ask questions about our data. So you'll see if you start running this application on your own computer, when you load in a new folder, it's first going to vectorize that data so that we can really quickly look up the data, and that's why we get such rapid replies. So the process: prompt, find the data you want from the database, inject it into the model, and then get an accurate reply based on that data. So that is my really high-level overview of how this application works. I hope it was helpful and gave you a little bit of insight into what RAG is and how it's used with these LLMs. That's going to wrap up this video. I encourage you to download ChatRTX from the link in the description and play around with it. It's really cool. And I look forward to seeing you in another YouTube video.